Okay, we're going to talk about the relationship between the areas and volumes of figures and solids. First, looking at the scale factor of two similar figures. These two rectangles are similar. So to find the scale factor, we take corresponding sides, which in this case would be 6 over 8, which simplifies into 3/4. That, if you recall, is my scale factor. Now if we find the area of each rectangle, 6 times 12 is 72, 8 times 16 is 128. Those are the volumes, or the areas of those two similar figures. Now let's make a ratio out of those and compare what those look like. 72 over 128. If I simplify that ratio, I end up with 16 over 9. Notice anything, you have 3/4 is your scale factor and our area ratio is 16 over 9. Notice that the scale factor is A over B and the area ratio here is going to be whatever my scale factor squared. Notice 3 squared is I'm sorry, I put those backwards, didn't I? Excuse me. Should be 9 over 16. My scale for 3 squared is 9. 4 squared is 16. Okay, so my area ratio is going to be the square of my scale factor. If two polyhedrons are similar, then the ratio of their areas is proportional to the square of the scale factor. Excuse me. Alright, moving on. So here I have an example. Here I have two triangles that are similar. We have side lengths here and here. Okay, so we're going to find our scale factor first since we have two side lengths of these two triangles. 12 over 15, which simplifies into 4/5. So that's my scale factor. Now to find my area ratio, remember it's going to be the scale factor squared. So 4 squared over 5 squared is 16 over 25. Once I have my area ratio, I set it equal to, now notice 30 is the area of JKL. We need to find the area of the other larger triangle, which we'll put an X there for that. So then we cross multiply, solve for X. 16X equals 750. Divide by 16, and if we're going to round to the nearest tenth, X, which is the area of PQR, equals 46.9 square inches. Okay, now if we're dealing with volumes, first of all, similar solids are where we have corresponding measures that are proportional. In this cone, the slant height would be proportional to the height, to the radius, to the diameter, to all of that. Okay, so we have two cubes. Remember, a cube is going to have the same length, width, and height. So find the scale factor and the volume. Well, the scale factor is 3 over 2, isn't it? Now, the volume, I'm just going to go ahead and tell you the area ratio. I would square the scale factor, which would give me 9 over 4. Well, the volume ratio, I cubed the scale factor. So 3 cubed over 2 cubed. That should be a 3 there. Which means that the volume ratio is going to be 27 over 8. And notice when I do multiply this out, the volume would be 3 times 3 times 3, which is 27. 2 times 2 times 2, which is 8. And there you have the same volume ratio. So, just a quick review. The scale factor is A over B. The area ratio is going to be A squared over B squared. And the volume ratio is going to be A cubed over B cubed. Let's look at some more examples. Determine whether each pair is similar or congruent or neither. Well, this one is these drawings are fairly easy because all we have to do is write see if the scale factors are equal. 1 over 5, those are corresponding parts. Is that the same ratio as 2 over 10, other corresponding parts? Yes, those two fractions are equal to each other. They're not, those two fractions aren't the same, those lengths aren't the same, so it's not congruent, but it is similar. Okay, now let's look at this next one. Corresponding parts, 2 over 1. Is that equal to 2 over 1? Yes. Is that equal to 4 over 3? Well, 4/3 is not equal to 2 over 1. Therefore, not only are they not congruent, but they are actually not even similar. So my answer would be neither here. All right, let's look at another word problem here. It says that two similar triangles have volumes of 27 square meters and 64 square meters. What is the scale factor of the prisms? Now, we're going to work our way backwards. If we knew what the scale factor was, we could figure out what their volume ratio would be. But if I have the volumes of 27 over 64, remember that's equal to the scale factor cubed. So what we have to do is we have to cube root it, and if I was to do that, I would have my scale factor. I would have my A and I would have my B. In order to cube on your calculator, if you're using the TI-30, make sure that you hit 3 first, then second, then the caret button, which is right below the pi button, and then put 27 in there. When you do that, you'll find that you get 3, and when you do the same thing for 64, you'll find that you get 4. That is your A and your B, which means that is your scale factor. It's just a way of working backwards. Okay. Looking at the next one, a small rectangular laptop has a width of 10 and an area of 80. Larger one has a width of 15, but we have to find the area. So we can find the scale factor because corresponding sides are 10 over 15, which simplifies to 2/3. We have to find the area. So if that's the scale factor, what's the area ratio going to be? Well, I take 2 and I square it. I take 3 and I square it, which is 4 over 9. So that's my area ratio. If I know my area ratio, I can find the missing area. Now notice 8 goes with the 10-inch laptop, which means we have that on top. So we're going to put 80 on top. And I need to find the volume of the other laptop, and I'll put that X unknown there. Cross multiply and solve for X. 4X equals 720. Divide by 4, and we find that the volume of the larger laptop is 180 cubic inches.